All right, guys, I told you in our next class, we are going to be solving past questions using the formulas that we have derived, okay? So, now we have a JAMB question here, 1998, question 36. And the question says, find the force of repulsion between 2-point charges, 5 microcoulomb and 8 microcoulomb, separated by a distance of 0.02 meter. And we're asked to take 1 over 4 pi epsilon to be 9.0 times 10 raised to the power 9 Newton meter square per coulomb square. Now, you see I'm going to solve this problem. We're also given options because JAMB is always objective question. Okay, so first and foremost, I'm going to bring out the parameters given to us in this question. Say find force of repulsion. So we are looking for force between 2-point charges. The two charges, their value are 5 microcoulomb. So we have Q1 to be equal to 5 microcoulomb, and we have Q2 to be equal to 8 microcoulomb. Okay, what else is given to us? Separated by a distance of 0.002, R equals 0.02 meter. Okay, we are asked to take pi, 1 over 4 pi epsilon naught to be 1 all over 4 pi epsilon naught to be 9.0 times 10 raised to the power 9 Newton meters square per coulomb square. So these are the values given to us. These are the values given to us in this question. So remember, our formula says that F is equal to Q1, Q2, all over 4 pi epsilon naught R square. Now, there's something I'm going to do to make it simpler. I'm going to say Q1, Q2, all over R square, multiplied by 1 all over 4 pi epsilon naught. This and this are still the same. I just want to see it is for simplification purpose, okay? Now, I will now substitute that value so that I have F is equal to our Q1 is, we are going to convert, this is microcoulomb, we are going to convert to coulomb. So converting to coulomb, you multiply this value by 10 raised to the power minus 6. So our Q1 is going to be 5 times 10 raised to the power minus 6. Multiplied by Q2, which we are also going to convert to coulomb, which is going to give us 8 times 10 raised to the power minus 6 times the 1 all over 4 pi epsilon naught. So this value, this 1 over 4 pi epsilon naught is given by this. So we are now going to say 9 times 10 raised to the power 9 all over the distance of separation between the 2 points, which is 0.02, and it is squared, all squared. Okay, so now I can say 5 times 8 times 9. I bring it outside. The bases are the same. I add the powers. So I will now say that F is equal to 5 times 8 times 9 times 10 raised to the power minus 6 plus 9. Minus 6 plus 9 all over. If you square this, you are going to have 0.0004. All right? So I can change this to standard form so that I'm going to count into 4 places. I'm going to move this point 1, 2, 3, 4. So that this is going to be the same thing as 4 times 10 raised to the power minus 4. Okay, so I'm going to change this to this. So that I'm going to have here that F is equal to 5 times 8 times 9 times 10 raised to the power minus 6 plus 9 all over 4 times 10 raised to the power minus 4. Okay, 5 times 8 is going to give us 40. 40 times 9 will give us 360. So that F becomes equal to 360 times minus 6 plus minus 6 is going to give us minus 12. Minus 12 plus 9 is going to give us minus 3. 10 raised to the power minus 3 all over 4 times 10 raised to the power minus 4. Now, I can take this 10 raised to the power minus 4 up. so that we are going to have F equal to 360 over 4 times 10 raised to the power minus 3 plus 4. 360 divided 4 is going to give us 90. F becomes equal to 90 times 10 raised to the power minus 3 plus 4 is going to give us 1 Newton is our answer. But looking at the options we don't have any option with raised to the power 1, 10 raised to the power 1. So what do? We know that if we move one place to the left, we add 1 to the power, and so we are going to arrive at one of the options, so that we say F is equal to 9.0 times 10 raised to the power 2 Newton. So that is our answer, and so the correct option here is what? C. Thank you. So we are going to quickly move into the second question. All right. We are going to solve another question, and this question is from JAMB 2013, question 36. Okay, and the question says, calculate the force acting on an electron of charge 1.5 times 10 raised to the power minus 19 coulomb, placed in an electric field of intensity 10 raised to the power 5 volt per meter, and they gave us option. It's a very simple question, so just quickly we are going to solve it. Solution. I told you the first thing to do is to bring out the parameters that has been given to you in the question, all right? Now, they say calculate the force. So it means they are asking us to find the force being exerted on this 1.5 times 10 raised to the power minus 19 coulomb charge. So the charge Q is equal to 1.5 times 10 raised to the power minus 19 coulomb. Okay? Placed in an electric field of intensity. So they gave us electric field intensity E to be 10 raised to the power 5 volt per meter. Okay, so I will now use our formula. I told there's a relationship between force, charge, and electric field intensity, and that relationship says that F is equal to QE. Okay, now I will substitute the values so that F becomes equal to our Q is 1.5 times 10 raised to the power minus 19 multiplied by our electric field intensity 10 raised to the power 5. All right, so F becomes equal to, I can just say 1.5, since the bases are the same, add the power 1.5 times 10 raised to the power minus 19 plus 5, so that F becomes equal to 1.5 times 10 raised to the power minus 19 plus 5 is going to give us minus 14. And the unit is Newton, because we are talking about force. And it is as simple as that, okay? Now, let's look at our option. We have option A, 1.5 times 10 raised to the power minus 12. That's not the correct answer. B, 1.5 times 10 raised to the power minus 13. Not correct. C, 1.5 times 10 raised to the power minus 14. So our answer is C. All right, so thank you. We are going to move into the third question. And the question, that is our last question for today. It says, the correct expression for the potential at a point, distance R from a charge Q in an electric field is, so what they're expecting us is to just give the right formula for electric potential, which is part of the derivation we did yesterday. Remember, we said electric potential V is equal to Q all over 4 pi epsilon naught R. Okay, so you can cross-check this against the options. We have option A, Q all over 4 pi epsilon naught R squared. That's not correct. We have option B, Q squared all over 4 pi epsilon naught R squared. That's not correct. We have C, Q all over 4 pi epsilon naught R. And that is the right option. Even though they use a test charge here, it is all the same. And here we have point charge. So the correct option is C. So that is the correct option. So thank you so much. Comment.